All right, today we're going to talk about section 8.5, which is theorems involving proportions, the different proportionality theorems. The very first theorem that we are going to be talking about is called the side splitter theorem. And the side splitter theorem states that if a line is parallel to one side of a triangle and it intersects the other two sides, then it divides those two sides proportionally. So we have the two parallel lines right here cutting through the triangle. So then it cuts each side of the triangle into an equal ratio. So we could have A over B from the left side equals C over D from the right side. You can also do it as the top parts in proportion with the whole side. So we could take A over the whole thing. So the top part on the left to the whole thing, the whole side of E, is equal to the top part on the right side to the whole side of F. And we could even do one more with the bottom B over E equals D over F. So there's different ones dealing with the splitting the sides of a triangle. Now that we'll look when we're actually solving, we have the parallel sides right here. So cuts it equal proportion. The proportion is actually already set up for you. X over 2 equals 5 over 3. And then we can go ahead and solve for x. The next one is very similar to this one, except it's not dealing with specifically a triangle. It's the parallel proportion. So we have multiple parallel lines that are intersected by two transversals, and the parallel lines divide the transversals proportionally. So same concept. We have the transversals here in blue, and then the parallel lines, so they cut the transversals proportionally. So on the left transversal we have A over B. On the right transversal it's the same ratio as C over D. And same as the other one, we could set it up as the top A over the whole E equals on the right the top C over the whole F. And you could even do the bottom ones, D over E and D over F. So you have multiple proportions you could set up for parallel proportion. An algebra problem of that, again, this one is set up. 6 over 9 equals x over 8. So when we cross multiply, we can solve for x and find out that the x value in this case is 16/3. The third theorem is talking about the angle bisector theorem. So if a ray bisects an angle of a triangle, then it divides the opposite sides into segments that are proportional to the adjacent sides. So this is the bisector. So if you put letters in for this one, you could put in A, B, C, and D. Divides the opposite sides into segments that are proportional to the adjacent sides. So the opposite side divides up into B and D, and the adjacent sides are A and C. You could also set it up same concept where it's dividing it right here. A over B is equal to C over D. The same exact proportion when you cross multiply. Algebraically, when you take a look at this problem, this one is a little different in the sense that it gives the whole side of the side that is the other side of the triangle, and if you have this one is x, we know that the whole thing is 13. We can say that this one is 13 minus x. So now we can set up a proportion with x over 5 from the left side of the bisector and 13 minus x over 12 for the right side. And then we can go ahead and cross multiply and solve for x. Now when we solve for x, we can get 65 over 17. We can go ahead and use that x value to solve for sides A, D, and sides DB. You can go ahead and do that, finish that for tomorrow. Go ahead and pause the video and solve for number 3, and then you can check your answer when you are done. So if you set this up where IH is x and then IJ is 12 minus x, you would get 9.6 for x. You could also switch the x and the 12 minus x. You would just get a different value for x. Either way, when you plug it back in, you get 9.6 for IH and 2.4 for IJ. And solving for y is probably one of the most common mistakes in this case. This is not one of the parallel proportion theorems or anything like that. This is dealing with similar triangles. Because of the parallel lines, we have corresponding angles in each case. And so y and 9 are both sides of the triangle. 8 is the side of the small triangle, and its corresponding side is 10, 8 plus 2, on the big triangle. It's in a equal ratio to y, a side on the small triangle, to 9 on the big triangle. And that is how you would solve for y. For number 4, we first need to draw an appropriate diagram. One side of a triangle is 4 centimeters longer than the other side. So we can draw a triangle. We know that one side could just be x and the other side could be x plus 4. And it says a ray bisecting the angle formed by these two sides. So this is the angle formed by those two sides. And the ray that divides that angle, bisects it, divides the opposite side into 5 and 3. Does the 3 go here, or the 5 go here, the 3 go here, or the 5 go there? So we need to put 3 and 5 in the appropriate spots. If you are unsure, solve it both ways and find out which one works, and finish finding the perimeter of the triangle for tomorrow. So you'll need to, if you are unsure which one it would go to, put 3 and 5 here and solve the ratio, equal proportion. And then you can set up another one with x over 5 and x plus 4 over 3. Only one of those is an accurate diagram for the triangle, so find out which one works and finish in solving the perimeter, and that concludes section 8.5.